by the time you get back, so that your orbit is, you've done one complete orbit, your orbit won't be above the point from which you took off because the Earth's rotated. And that requires a capability called cross range on re-entry. Basically means that you have to change your trajectory so that you compensate for that rotation of the Earth and can fly back to the same point you launched from. And that was the basis of the design of the shuttle as it was built. It was built on US Air Force requirements. And that's why it's a big fat delta, because you can get quite a lot of deviation in the orbit by basically doing a re-entry with a very large flat heat shield. You basically steer the whole thing through the re-entry process, and you can go back to where you came from. Now, that requirement was an obvious one from the point of view US Air Force doing reconnaissance over potentially hostile states. But it wasn't really of interest to NASA. And the design that they came up with was extremely demanding and quite stressed. And you would probably have noticed that there were two major disasters with the shuttle. One because of a fault in the solid rocket boosters, and the other one because of a problem with the tiles that protected the heat shield on re-entry. And it's arguable that both of those problems were the result of that requirement for cross range. Both of them put considerable stress on the vehicle. The re-entry trajectory for the shuttle was very much more demanding than it need to have been because of that cross range requirement. So that was to some extent the cause of the second disaster, which was on re-entry. The first disaster, the solid rocket booster problem, was basically there because they were trying to get into space very much more quickly than some of the NASA designs had required, and so they used big, crude, like basically versions of the solid rockets that they were using to launch weapons from nuclear submarines. So SRBs, solid rocket boosters, as they were called, and they were not sufficiently safe, really, for human missions. And that was the fundamental cause of that disaster. And there was an engineer within NASA called Faget, Faget, who was a proponent of an alternative design, of which the booster part of the shuttle would have actually been in another aircraft. So there'd basically be two aircraft stacked one on top of the other. They'd still have launched vertically.
Wait, so there were like two aircrafts like colliding, or like
yes. I mean, you still have to glide, really. I mean, that's the economics of the situation with respect to
and
fuel.
was there
and thrust.
like what happened next? Did the rocket just got destroyed, or like?
Yeah, I mean, if you look at there's a film. There's a TV film called Challenger, and of course the shuttle that exploded because of the solid rocket boosters was called Challenger, but it was a reference to the scientist who Richard Feynman, who was the science expert on the committee of inquiry that took place afterwards. Very well played by I've forgotten his name, actor who's now died. But Feynman, right at the end of his career, he died when he was only 70 years old. But if you've not heard of him in the development of particle physics, then he was one of the prime movers in the middle years of the 20th century. But he was the one, with help from some of the other members of the team, who exposed the cover-up of the problem with the solid rocket boosters. That film dramatizes it quite well, but there's quite a lot of other published material about how that disaster happened. I mean, basically, it was that the segments of the booster were held together with bolts, but they had to be sealed in some way, and the seals, the so-called O-ring seals, were basically just rubber, and the design relied upon that rubber maintaining some of its flexibility during the launch phase when the SRBs are being used. And it turned out that at the launch, the temperature was so low that the flexibility had gone out of those.
So that was basically the temperature of space?
Yeah, no, the temperature at the launch site. It was a freezing cold day in Florida. You don't get those very much in Florida, but it does happen.
Okay.
On that freezing cold day, they should not have launched because
that was like on launch day. Yeah.
Sorry, say again.
I was saying that was like on launch on
launch
day.
At
Yeah.
the point of launch. Yeah, it was actually really, really cold, and the SRB O-ring seals just did not do the job, and they leaked. And all it takes is a very small leak, because once that happens, then the what is effectively part of the rocket continuous explosion, which is how a rocket works, of course, that just burst out through the side of the solid rocket booster. It hit the big tank that was carrying most of the fuel, and the whole thing just exploded as they were launching. It was obviously an appalling spectacle, and it killed all the people on board it. So basically it was a flawed design, and Fadget's design was much more practical, but it would have taken longer to build, and it would certainly not have had the cross range that the US Air Force required. The ironic thing about that is that when that disaster happened, the US Air Force lost interest in the shuttle. They didn't want to be involved with it anymore, and they used basically throwaway rockets. After that, they completely lost interest in a reusable spacecraft at that point. So the first thing that went wrong was related to that fundamental requirement. Yeah, it's an engineering sort of truism, really, that if you try and push too many requirements into a single project, you're asking for trouble. And basically, they were trying to build a reusable spacecraft with effectively two divergent objectives, one of which was the science and the development of the engineering of launchers, and the other was a military objective, or perhaps more accurately, an intelligence objective.
Okay. So someone wanted to speak.
Sorry, go ahead.
Yeah, hello?
Oh, wow, we have a oh, somebody's joined and then disappeared again. Okay. Shall I say a bit more about the rest of my career?
He just wanted to say something.
Yeah, go ahead.
Yeah, hello, can you hear me?
Yeah.
Yeah, so I just wanted to ask about what do you personally think about the Voyager Golden Record as a message to any extraterrestrial civilization?
Oh, you mean the golden record thing?
Yeah, the Voyager. Yeah.
Yeah. That was Carl Sagan put that together, I think, and a very inspirational guy, Carl Sagan. If you look at some of his programs that he made, sadly also died relatively young, like Feynman. Yeah, I mean it's it's a sort of lesson from its time, actually. The two naked human figures are very obviously Western European or white North American. It doesn't really represent humanity very well, at least visually. And I suspect all the material on it was. I think Sagan tried to make it relatively broad across humanity, but it basically failed in that. It was a brave attempt to produce a message that might be interpretable, but clearly the chances of it actually being picked up, certainly within several million years, are tiny. But it was a first brave attempt. in communication with extraterrestrial intelligence is very controversial, and certainly doing it at light speed with what effectively would be an hour radio transmissions is extremely controversial, and we could talk some more about that if you're interested. But yeah, the golden record was a brave attempt. Okay.
So I had a question, and that question is like, I've recently seen, like, ever since like 2019 or 2020, about the LiDAR camera that's used, so they could, check Mars and kind of scan the objects that surround that planet, So
Sorry, what was I missed the word, something something camera. What was that?
it's like sort of like between an infrared camera and a camera that scans objects. It's called LiDAR.
LiDAR. I've heard that word used to mean using basically laser beams instead of microwave pulses to do the equivalent of radar, but in the visible spectrum. That's my understanding of what the word LiDAR means. But this sounds like something different from how you're describing it.
Yeah, it's like similar to, basically any infrared camera, but this time it's like more updated. Like it has more new, like it's pretty much a new camera that they've made, by NASA, so they could like check Mars.
Yeah, I wasn't aware of that. I mean, clearly there's lots more beyond the visible spectrum that you can find out from a camera that's capable of that. I mean, just to give you an example from my own very early career, one of the things I worked on, another design study I worked on during that relatively few years, I was in that particular space technology company, was an infrared. Effectively, it wasn't really a camera. It was no more than a detector system in a low Earth orbit satellite, which measured the temperature of the atmosphere at different altitudes below the satellite as it flew around the Earth for weather prediction purposes. Yeah, so you'd want to do that with respect to Mars as well. Mars does have an atmosphere, a thin one, but its atmosphere does affect things quite a bit. I mean, a lot of the dust on the surface of Mars is basically the consistency of talcum powder. It's very, very fine dust, and so it doesn't take very much of an atmosphere to move it about when winds blow on Mars. So you do get effectively dust storms, and I think in some cases it masks the entire surface of Mars. You get a dust storm that basically means you can't see the surface. So that's clearly very important in the case of Mars, to have a wide spectrum observation of the surface.
So like there is like high winds that blow in Mars, and that's
Yeah, I mean, but the winds don't blow anything very much. Have you seen the film The Martian? You may have seen it.
I think I've heard about it.
Yeah, there's a scene in that film which is basically nonsense. It's part of the drama, and I quite like the film in general, but there is a scene early on in the film which is, as I say, is nonsense from a scientific point of view, and it is that there is one of these storms on Mars, and it's they're worried that it's going to blow their exit vehicle, the vehicle that we're going to fly back to Earth from the surface of Mars. It was going to blow. That vehicle is sitting there vertically, ready to take off, and the danger is supposed to be that wind is going to blow it over. Now that is impossible, given the thinness of the Martian atmosphere. The wind can blow at hundreds of miles an hour, and it is not going to move anything much other than that very fine dust. It will definitely not push the vehicle over. There is not the remotest chance of that. And yet that's the reason why they have to leave the guy behind on the surface of Mars, because they need to launch before the vehicle topples over. And that was nonsense, basically. So, yeah. So the storms are important, but they're not as important as is implied in that film.
Okay. Okay, you can go ahead.
Yeah. Okay.
No,
so,
I meant with the student here.
Okay, go ahead. Yeah. Yeah. Waiting.
Yeah. Um, if someone were to want to be an astronaut, how would that happen? Do they just pick a random space engineer, or do they need someone with
No,
experience?
that used to be basically that they hired fighter pilots basically originally, test pilots. Although, funnily enough, there was a very little control by the astronaut of those early space vehicles. So the skills of being a pilot were not particularly appropriate, but nevertheless, that's what they picked. And the military provided a lot of the sort of astronauts, and I think still does to a large extent in all countries, really. I must take more of an interest in the Indian space program, in particular their move to put some actual humans into space, which I think they're going to do in the next few years. I don't know whether that's dominated by Indian Air Force people, but there's a lot of civilian astronauts. I mean, the last of the Apollo missions was the main investigator on board was actually a geologist, and that was his specialism. And since then, astronauts have been from many different sources. I mean, one way to get into space is to get very, very rich by some other means, and then pay to go into space. That's one fairly certain way of getting yourself a trip into space. Yeah. But maybe that's not what you're aiming for.
So go ahead, Dino.
Yes. So I've actually watched the Martian movie, and I've seen that scene where the guy he actually like plants food so that he can eat, so that he can survive on Mars. You think that's actually possible to do, and is it actually like possible to live on Mars in the far future?
I suspect it is. I'm not a biologist, and you'd need to be a biologist with a specialism in crop vegetables that you could leave. I mean, he grows potatoes using his own human waste to fertilize it. And that, as far as I can tell, looks reasonably plausible. And that's certainly for a self-sustaining community on the surface of Mars. Something like that would have to be the case. You really cannot afford the expense of having to fly all the food and other essentials of human life all the way from Earth to the surface of Mars. It's just not sensible, even with the monster launches that SpaceX is building. So you have got to be to a degree self-sufficient. It seems to me, I'm an engineer, not a scientist, but it seems to me that the greatest challenge of living on the surface of Mars is radiation, because
so it basically radiation. That's the only effect that's happening in Mars. Like, if this problem is solved, that way people can live in Mars.
If you can get around the radiation problem, I suspect that the other problems are probably much more easy to overcome. The problem is that Mars doesn't have
like, can a person breathe in Mars, or of course it, like, there's no
no
oxygen?
no no. I mean, the atmosphere is so thin that there is no chance of, and in any case, what there is of it, I think, is mostly carbon dioxide. No, I mean, there is fairly certainly quite a lot of ice, water ice, buried on the surface of Mars, and that's relatively easy to convert into hydrogen and oxygen, obviously, and And from those things, you can derive obviously fuel and air to breathe. So it's with the resources that are there on the surface, it all looks feasible, challenging but feasible. The radiation problem, I mean, there have been suggestions that you might have to live in a cave, that you would really never or very rarely see the sky. You would basically have to be a cave dweller on Mars, and that would require a big change in human psychology, I think. The basic problem is that Mars lost its equivalent of our Van Allen belts, which are belts of magnetic belts that surround the Earth and that keep both the radiation from the sun and galactic cosmic rays from making the surface uninhabitable. But there are no such belts around Mars. So you have to find some other way of dealing with that radiation if you want to live there as a human, or in fact just about anything biological. Probably some insects could survive, but we're not very interested in taking insects
Okay.
to Mars if we can't go ourselves.
Dino wanted to ask a question. You
Sure.
can go ahead.
So I just want to ask, the gravity on Mars, like, what's like if a human went to Mars, like the gravity difference, what would it do then?
Yeah, I think you'd get some of the same effect as you've seen on the moon. Have you seen videos of the astronauts on the moon, the Apollo mission astronauts, where they could bound along in big steps, but it's not so much as that on Mars. Mars gravity is quite a lot stronger than the gravity of the moon, so you get a similar effect, but not quite so exaggerated. One of the problems with existing in space is the lack of gravity and the biological effect that has. It causes various kinds of wasting of the human body, which is why astronauts have to take so much exercise if they're going up to the International Space Station for any length of time. And the same applies with the new Chinese space station. They will have the same problems. So the absence of gravity is the problem there. I suspect that Mars is a lot more survivable in that sense. You may not need to spend half your day doing exercises on the surface of Mars, because there is quite a considerable amount of gravity, a lot more than in space, obviously, and quite a lot more than even on the surface of the moon.
I also read the book named Dark They Were and Golden Eyed, where I think a group of humans went to Mars and like made a civilization there. I don't really remember the book, but they had physical and psychological advances when they went to Mars.
Yeah, I mean, that title is actually the title of a science fiction bookshop in London that I remember. I don't remember there being an actual story with that title. I don't know where they got that from. Yeah, I mean, it's perfectly possible that there will be some sort of civilization, particularly if the radiation problem can be solved. My personal feeling is that we have a better chance with O'Neill colonies. If you've read Gerard K. O'Neill's book, The High Frontier, it's about 40 years old now. That suggests that we would actually be better building settlements in space, which would rotate and therefore give you gravity, but would be something like, say, 50 kilometers long and 10 kilometers in diameter. So it'd be massive things. You'd have to build them out of resources that were available up there from asteroids and possibly from the surface of very low gravity objects like the moon. Obviously not from Earth. It's just not economic. So those sort of space colonies strike me as being a better option than the surface of Mars. And there are good economic reasons for that too. If you look at the gravity in effect, the geography of the gravity wells in the solar system. If you're in space, well away from any planets, the power required to move from one place to another is very low. So if you've got commercial activities that require you to move things around, as long as you don't go near planets, then the economics of moving things around are very attractive. It costs very, very little in terms of energy to move around, as long as you don't go near a planet.
Okay. So, well, one of the students wanted to ask something. You can go ahead.
Yeah. As an astronaut, if somebody what's the maximum amount of time somebody can spend in low gravity before they face really severe consequences?
Yeah, I mean, that's what the International Space Station has been exploring. And certainly, I think 6 or 8 months is about the longest that there has been. But I haven't looked at the biological studies for that. There will be papers published about this that you could probably research. But nobody's tried to stay up there longer than that. And as I say, it demands a tremendous amount of time spent exercising. I think that problem will be largely solved once we build rotating space stations. Have you seen the film 2001: A Space Odyssey? Way back from the 60s. You seen that film?
No, I don't think so.
Yeah, it's most people think it's the best space film ever made, even though, as I say, it's about 50 years old. And it part of it shows you a space station in low Earth orbit, which is actually based on ideas of Werner von Braun, the German rocket engineer. And it's basically just a big wheel, and it rotates and gives you something close to Earth gravity inside the rim of that wheel. And in those circumstances, you've got Earth gravity, so you don't have to spend half your day on an exercise bike or whatever it was, or whatever it is on the space station. Yeah, so I don't think there's any limit to how long humans can stay in space, provided they're protected from radiation and they you could supply them with gravity.
Okay.
And protecting from radiation is rather easier in a spacecraft than it is running around on the surface of Mars. Although, of course, your freedom of movement is more restricted.
Okay. So, Dino wanted to ask something.
So, sorry, I want to ask a question. Have you watched the movie Interstellar?
I have, yes.
So yes, there's this scene where Cooper he goes to this planet and he leaves one of his I don't know, his friends behind, and they talked about something about a time difference where, like, if he spends that much time there, it's gonna pass so much longer in the back in the space thingy.
Yeah, and in fact, he manages to fly back to Earth, and he's only about just a few years older, and his daughter, who he left behind, is now an old woman. You perhaps remember that scene. I mean, that's just a consequence of time dilation, as in Einstein's special theory of relativity. That's an inevitable consequence of traveling at that sort of speed, if it can ever be achieved. I mean, they use a wormhole in Interstellar, and nobody knows whether there are any wormholes. There's no evidence that any exist. There's various other theoretical ways of breaching the light speed barrier. If you look up the work of a guy called Miguel Alcubierre, that's Alcubierre, Alcubierre. He wrote a paper when he was at the University of Cardiff in the UK that suggested that you might be able to effectively create something like a space warp, as in the original Star Trek stories. But if you look that up, it's still relatively controversial as to whether it could ever be achieved. So there are, in theory, ways of cheating the light speed barrier. My own suspicion is that the way we'll get around it is that it will only be artificial intelligences that can travel interstellar distances, and those artificial intelligences, of course, can travel at the speed of light because they're just information, so you can transmit yourself around if you're an electronic person rather than a biological person. But we're still a long way from that. The AI we've got at the moment is pretty crude by comparison with what you're going to need to in effect send something equivalent to a human to the nearest stars.
Okay, so one last thing is that, like, what advice would you tell to the students, like something that you wanted to know at their age?
I think I would have paid more attention to my university's way of dealing with students. I was a brand new student. I had no mentors in effect, and I didn't appreciate that I was going to end up with a relatively low standard degree, simply because of my results in my previous exams, which were not brilliant. And that's partly why I did a master's degree subsequently, although of course I was more interested in computing, so I did a master's in computer science. So that's an early lesson, and particularly if you're new to an area, whether it's academic or business or whatever. Find yourself some people who can advise you about the situation you're in. If you've got family that have got experience in that same area, fine. Or if you have close friends through your family, then likewise. But finding good mentors at an early stage is extremely useful. I suppose the other thing I'd say is that some of the most successful people I've known of my generation never went to university at all. There's a guy who ended up as a main board director of one of the bigger companies in the UK, who left school at age 16, with very limited qualifications, but he was a brilliant engineer and a good manager, and he rose and achieved that before he retired. And he's not the only one. I've known several others who didn't in the end go to university, but they went into good apprenticeships in firms. I don't know whether that's something that exists in your industrial culture.
Okay, so now we're gonna be, since there's 5 minutes left, so if you guys have any small questions that Mr. Davies, you can go ahead and ask, but just ask quickly since there'll be 5 minutes and then the meeting is gonna close. Since we stayed for about an hour now, so.
Okay.
So Ahmed, do you want to say something?
Oh, sorry, I didn't know you were talking to me. I'm currently outside. But it's so nice to see you, John. You're talking to the president of Some Club. We're very good friends with Muhammad. But it's great to see you here, and it's great to see everybody here.
Well, thank you.
I'm
Yeah,
sorry I couldn't attend.
I think perhaps before we close, I'll just say a couple of things about the organisation I work for now, which is the Initiative Institute for Interstellar Studies. We are looking into the relatively near future and also the far distant future. And we include people like spacecraft engineers, physicists, and just plain enthusiasts, which I suppose I am, although I do have qualifications and experience that are relevant. But it's important that there are organisations like this. I mean, it's because of organisations like this that, for example, Wernher von Braun and his team, they came up through something called the Joan Rocket Society in the 1920s. the American Rocket Society in the 1930s inspired people who later went into NASA and into spacecraft engineering. So these advocacy organizations are quite important, and if you could find one in your vicinity, and I don't know if there's a branch of SEDS, Students for Education and Development to Space. Certainly, I don't know if there is in your country. We have a UK SEDS, and there is the original American SEDS. So student organizations like that are quite important. They're good ways to get contact with industry as well if you're looking for a job when you graduate. I don't know if they exist in your country.
I'm not sure either. Yeah.
Look them up. SEDS.
All right. Yes. Well, yeah, okay, so there's one in Egypt, but I'm not sure if there's one in Saudi Arabia.
Right.
Yeah.
There is certainly
Well,
an international.
I'm sure.
I'm actually from Egypt.
There's like other branches. Yeah.
By the way, I'm from Egypt.
You're from Egypt, yeah.
Yeah.
One of my colleagues is from Egypt. She's actually in Dubai now. She graduated from the University of Cairo about 10 years ago.
That's nice.
We have quite a broad spread across different countries.
So right now, thanks everybody for joining. Now say goodbye to Mr. John Davis. I want you to say one Arabic word, and that is مع السلامة, which means goodbye. So مع السلامة.
Thank you. Good to talk to you.
All right, thank you for attending.
Yeah.
It was really
Bye.
nice.
Thank you.
Goodbye.
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 Right.